Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 13, Section 5. And in this video, we're going to be talking about identifying functions using equations and identifying functions using tables. And the two types of functions we're trying to identify are linear versus nonlinear functions. Like we discussed in the previous video, linear functions create straight lines. Nonlinear functions create curves and waves. So if we are going to identify a function using an equation, basically all you need to do is understand what makes up a linear equation. And if you know what to look for a linear equation, pretty much everything else is nonlinear. There are three things you're looking for with a linear equation. The first thing, variables should not have exponents that are visible. Every variable always has at least an exponent of 1, but we don't write exponents of 1, which is why I've said variables should not have an exponent, and I should say variables should not have an exponent that is visible, because we don't write exponents of 1. If you see an exponent of 1 on a variable, it is okay, but we typically don't write it, and there's really no good reason for writing it. So variables should not have exponents. There should be two different variables. In two different terms. So, when I say two different variables in two different terms, I mean that y and x cannot be attached. This is not a linear equation because y and x are in the same term. I need two and only two different variables in the same term. I don't want three different variables. I want two different variables. Not in different terms. I want them in different terms. Now, if you had something like y equals 2x plus x plus 4, this is still a linear equation because this hasn't been simplified yet. While this may have three variables, it doesn't have three different variables. It actually only has two different variables. I can combine 2x and 1x and turn this into y equals 3x plus 4. So keep that in mind. This is still a linear equation. Now, if that x that's by itself, if this was actually a z, that would no longer be a linear equation. Probably a good idea to pause the video and write down those examples if you didn't do so. Remember, you can rewind the video. So variables should not have exponents. There should be two different variables in two different terms. And x cannot be in the denominator. Okay? X cannot be in the denominator. If any of these three things are true about the equation that you are looking at, then you are looking at a non-linear function. If all of these things are true, then you are looking at a linear function. Remember, these are the rules for a linear function. So if any of these things are broken, if any of these rules are broken, then you're looking at a non-linear function. Okay, pause the video if you need to write this stuff down. I'm moving on. Next thing we're going to talk about, identifying functions using tables. Remember, linear functions have a constant rate of change between x and y. X and y are constantly changing at a constant rate. Okay? Lines move in one direction, so there's a constant rate of change. I'm either going up 1 over 2, up 1 over 2, down 3 over 7, down 3 over 7. The same thing is happening over and over. So x and y are constantly changing at the same rate. So, for example, you have a chart. And we have 10 and 120. We have 15 and 100 and 20 and 80. And we have 25 and 60. If you take a look at x, x is plus 5, plus 5, plus 5. Y is plus 20, plus 20, plus 20. Or minus 20, I should be saying. Minus 20, minus 20, minus 20. So there's a constant rate of change here where y is decreasing by 20 and x is increasing by 5. If, however, it looked like this, and y had a and in this case x has a constant rate of change, but y is decreasing by 20. It's decreasing by 45, decreasing by 50. Then this is no longer a linear function. This is a nonlinear function. And typically in a nonlinear function, it's going to look slightly different. Typically the rate of change you're going to see over here is going to be it's going to be getting y will increase by a greater amount each time. So it may increase by 12 and then 20 and then 28. So it's the increase is being increased by 8. So like let's say for example we'll go 10, 22, and then 42, and 70. So it went plus 12, plus 20, plus 28. And so as you can see, the amount that's being increased is plus 8. But the actual increase itself is getting bigger and bigger by the same number over and over. So that's typically pretty indicative of a nonlinear function. But basically, linear functions have a constant rate of change. Nonlinear functions do not. So that's all there is in this video. In the next video, we're going to be talking about quadratic functions, cubic functions, exponential functions, and inverse variation functions, and what do those look like, and why are they, and specifically we're going to be looking at too, why are quadratic functions called quadratic functions, and why are cubic functions called cubic functions. But we'll just be giving you a little preview of what those are. We're not going to be doing a whole lot with them in this section, but I would like to preview those terms and concepts and give you some visuals and a little bit of understanding at this point. So tune in for that video, and then after that we'll be looking into Chapter 13, Sections